Hi everyone, this is Steve Davidowski, Chem 343 TA here at Arizona State University. Today I'm going to be talking to you a little bit about the experiment 3 in our PChem laboratory, the keto-enol equilibrium studied using NMR spectroscopy. And so here's just a little schematic of the keto form of the acetylacetone isomer, and the resonant forms shown down here are representative of the enol form of the acetylacetone. And so today I'm just going to show you some of the mechanics of how to import NMR data and how to integrate the peaks using KaleidaGraph. So that should be enough to get you started on your data analysis. And so the integrations of the peaks corresponding to these molecules in solution will give you an idea of the ratios of each of them, so you'll be able to calculate the equilibrium constant. So we'll just minimize that. And so now I've already downloaded this data onto my computer, so you'll be able to see here on the Blackboard site under Content and Experiment 3, you'll be able to download this data, the solvent-dependent data and the DMSO temperature-dependent data. So I've already downloaded that and put it on my computer. And so now the first step you'll need to do is to import that data into KaleidaGraph. So just File, Open, and then you should be able to navigate to your computer, navigate in your computer to find where your data is saved. So mine's just saved in the Documents folder here, so I'll just open that data set up, just the 25° C one. So it starts with a bunch of text. You'll need to skip these 10 lines of text because all we're interested in is the data. You also want to be sure that you're not reading in the titles because there's no title here. There's no text, it just starts with data right away. Tab, there's one tab in between each of these spaces, so these are the settings that we'll need to use to import this data set. So when we click OK, if everything goes according to plan, you can see that now we have a single column of data, and these are just our intensities for the 25° C. So we'll just label this as intensity, and I'll just cut and paste this column over here because this is our y-axis, so it's a little easier if you just put it in the second column. And then this is where we'll generate our x-axis for this plot, the chemical shift. So an NMR plot is chemical shift on the x-axis and intensity on the y-axis. So this data set only gives us the intensity, so we'll have to generate our chemical shift axis as you've done in experiment 1. So this is mostly review for most of you, I think. So now that we've imported our data, we need to open up this raw data text file, and this is where all the information is about where our x-axis is. So now we'll minimize this here, and then we'll bring up the calculator. So any calculator will do, you don't have to use the one on your computer. And so now we will calculate the increment for this in order to generate our x-axis. So this data shows right here our left limit of our NMR spectrum, so about 18 ppm, the right limit of our NMR spectrum, so about -2 ppm, and it tells us the size of our data set, so how many steps it takes to get from 18 to -2. So we know that our x-axis will be about 20 ppm. So 18.02594,94947 minus a negative, same thing as plus a positive, so I'll just add 2.01324025. So when we do that, we get something about 20, so that's right. And then we divide by 32768, and this will be our increment for our data set. So now, I'll just close out of this extra window here. So now we've got our left limit, our right limit, and how much each step increments. And so now we'll go to, so first we'll need to highlight this column to make sure that, so you need to have it highlighted so that it's all blue all the way down, and then we'll go to Functions, Create Series, and now we'll generate this x-axis. So our initial value is going to be that left limit, so 18.02594,94978, and then our increment is going to be negative 0.00611547.5. So the reason that it's negative is because we're starting at 18 and we're counting our way down. So this data, the intensities have given to us from left to right, and in an NMR spectrum, left is increasing. It's got a reverse axis of what you'd normally expect. And so it starts at 18 and counts its way down to -2. And our final value will be -2.013240251. Okay, and we want to make sure that's checked off. So this is what your box should look like if you're generating the chemical shift axis for this experiment. So now you can see we've generated the chemical shift scale for this. And so if we wanted, right now we could plot this NMR data and we would get a proper looking spectrum. But the thing about KaleidaGraph is that it doesn't like taking integrals of things that have x-axes that are counting down. So there's a pretty simple solution to this. What we'll do is we'll just use the sort ascending tool. So first thing you want to do is make sure that you have this whole column here highlighted, the whole chemical shift column highlighted, and then you'll click on this sort ascending tool. When you do that, this window will pop up here. And what this window is saying is basically first key. This is saying, alright, I'm going to sort this ascending, so it's going to start at -2 and count all its way up to 18, which is what we want. And this is where we choose which columns we want to sort. So we're going to just make sure that we have both of these columns highlighted. So it's going to flip it based on the chemical shift value, and it's going to bring the intensity values along with it. And so when we click OK, now it's flipped our axes here, and so you can see that now this is counting from -2 up, and it brought the intensity values with them. These are the intensity values that were all the way at the bottom of our spreadsheet before. And so we've got one little extra piece of data here, so we can just right click and then click delete row, and that will get rid of that. So now when we go up to gallery linear line plot, we can generate a plot with our x-axis being the chemical shift and our y-axis being the intensity. And you can see now that we've generated an NMR spectrum in KaleidaGraph. So you just change that marker to a little dot here and make sure that it's size 0, so it's just the lines here. And so now we can look at our NMR data. So, and we can format it a little bit. The axis options, usually the axis is reversed in NMR spectrum. So it starts at 0 on the right and then counts its way up here. So now we can pretty easily integrate this spectrum. I'll demonstrate very quickly how to do that. So the first thing you want to do when integrating a peak is to zoom in on it very close, and using the zoom tool here, zoom in very close and find where the peak limits are. So this peak looks like it goes from about 5.63 to about 5.7 is what I would say. So now I'll just bring up a little text document here. And if we were integrating this entire spectrum right now, I'm just going to demonstrate how to integrate one peak, but if we were integrating this entire spectrum now, we would want to write down the limits for all of these peaks. So I'll just say peak 1, 5.63 to 5.70 is about what I said, I think. Yeah, and so then we would go through and list all the peaks, and then we'd be able to integrate them easily later on. Alright, so that's the limit of what we need that plot for, just to get the integrals. And so now what we'll do is go up to macros, and so my macros are actually empty right now, so I'll go and import them very quickly. If your macros have the integrate function here, then you don't need to do this step. I just need to do this step because I've emptied my macros library. Append, and now I'm going to find the KaleidaGraph folder in my applications folder. If you're on a PC, this is in the programs folder. It's not in the applications folder. Then we'll go to examples, macros, and then just default macros. Gives us the integrate macro that we need. So now we'll go up to macros, integrate area. So if your macros look like this, then you don't need to do that last step. So macros, integrate area, and so now it asks, where's your x column, where's your y column? So our x column is in column 0, see it shows right here, column 0. KaleidaGraph begins counting its columns at 0, so column 0 is our x column, column 1 is our y column, we click OK, and then it asks you what the limits are that you want to integrate, and so we want to integrate from 5.63 ppm to 5.70 ppm, leave yref as 0, and then we're ready. Then it gives us the area under that peak in our plot. So that's literally the area associated with this plot here, associated with this peak. the area under this peak here is what we just got. And so I just copied that to the clipboard, and now I can paste it to anywhere that I want. If I wanted to put it in a new data set, or if I wanted to put it anywhere else, I would be able to do that. Alright, great. So that's how you integrate peaks in an NMR spectrum. And so I'll show you just really quickly a Mathematica script that I've worked on, and I'll probably send out. And this just helps you. This is similar to the one that Dr. Yarger has posted to our Blackboard site. This basically just defines K, so area of the enol, area of the keto, the error in the area of the enol, the error in the area of the keto, and then it defines what K is, and it defines how you get the error of K. And so this function here might look a little scary to you, but basically it's the same function that's available in our propagation of error sheet available on the Blackboard site. And so it's just an adaptation of this specific general propagation of error function here. So that's where that function comes from to calculate the error. And so this is the function that you should use for all of your propagation of error. And this function basically, when you would put your values for the areas here and your value for the errors of the areas here, and then when you hold down shift and hit enter, it'll just spit out what your K value is, your error in K, your ln of K, and your error in the ln of K, which is important for your subsequent plots and analysis. Alright, well, I think that's pretty much everything I plan to cover in this screencast, so thanks for watching.